Good morning, everybody. Welcome to day 2 of AVEVA World. I'm Jim Chappell, and Lori and I are going to talk about AVEVA AI this morning. We're going to talk about how it generates impact and to achieve greater goals, but across all industries. First, I want to talk about what industrial AI is. There's really 3 areas of industrial AI, for pragmatic use, because at AVEVA, we don't do AI for AI's sake. We do it as part of our industrial portfolio, as part of some of our industry-leading software, and match it with our domain expertise. But the 3 key areas that we use from a pragmatic perspective are unmatched speed. You've got all this data. What if you can run AI against it to get new knowledge out of it, to get new information, all types of AI? And it can do it so quickly, much faster, certainly than humans, but even other types of software. Then there's the complexity aspect of it, where you can navigate complex processes, multivariate, and so forth, and detect things that humans and other software cannot. And then there's the automation. It's constantly learning. It's constantly simulating and predicting and just on autopilot 24/7. And these are powerful capabilities that we use throughout all of our software, from design to operate to optimize and data. So we've been doing AI for over 20 years, predictive analytics, but now it's all types of AI across the board. And again, like I mentioned, we leverage our domain expertise and our industry-leading software to combine that in there to get maximum value and push it to the limits. So today, we're up to 18 commercially available software packages, or AI-infused software solutions. And many of them are a big help in the sustainability world, and we'll talk about that as well. One thing we get asked a lot is, what's your AI strategy? What do you guys do in AI? And I really boiled it down to 3 simple things. One is we've been infusing AI for 20 years into different solutions to make them better. But then we've been integrating multiple types of AI together. There's many types of machine learning. There's deep learning, reinforcement learning. There's neural nets. There's genetic algorithms. Of course, GenAI, like ChatGPT with large language models. There's expert systems, all kind of stuff across the board. And we integrate where it makes sense. We use the right type of AI for the right solution. And ultimately, we achieve this intellect. We call it knowledge linking, where it becomes a dynamic knowledge graph. And it's super powerful. And this is part of our industrial AI assistant that we're going to talk more about a little bit later. But we do it across design, operate, and optimize. We make our engineering designs better, more performant, faster handover. We make our operations smarter, more responsive, and more reliable. And when you do that, it's the help toward net zero. And so what do we do, realistically, what do we do to help our customers achieve net zero? Let's talk specifics. Well, one is whether you're building a better factory, plant, facility, designing it, or whether you're improving your operations, optimizing things. It could be, asset reliability. It could be optimizing processes. It's making things more efficient. And when you do that, you're burning less fuel. You build a better factory, you're burning less fuel. You improve your asset performance, you're burning less fuel. You improve your operations, you increase efficiency, burn less fuel. And that's a step toward net zero. But ultimately, we actually go to the source, and we've been doing this for a number of years, working with wind farms and solar fields and things like that, and we help drive down the cost of it. But how do we do it? Well, if you look at a solar or a wind farm, there's about 2.5 failures. Studies have shown about 2.5 failures per wind turbine per year. And so if you have 100 wind turbines in a wind farm, just as an example, that's 250 failures on average per year. If you can find those failures early, days, weeks, months before any type of control system or anything else would alert you to them, you can dispatch crews very early on and very efficiently and fix them all before they actually fail. So you end up producing more power, and you increase the reliability because you're fixing them before they fail. And when you do that, when you drive down the cost of renewable energy and you increase the reliability to where it's equal or greater than traditional forms of energy, in forms of energy production, you're moving to net zero. That's going to achieve net zero, because then it's not only an environmental thing, it's a fiduciary thing. It's money. And every company in the world is going to just massively do it quickly. And that is the AI-driven digital twin. That's a big step toward achieving net zero. And this is a good example of how AI can help. It can help on the front end to improve efficiency today, and help on the back end on the production of the power itself. Because once it's all green, then the usage of energy from a carbon footprint standpoint is irrelevant. So if you look at what we do, I mentioned we have 18 solutions. These are some commercial AI capabilities that we have across design, operate, and optimize. Here's our portfolio, where we have engineering and execution and operations control and asset performance, production optimization, planning and scheduling, simulation learning. And we do AI across every single area of that, end to end, design, operate, optimize. We do things with our E3D, unified engineering, where we've infused AI into that. AI and simulation. We've got, things where we've infused different types of AI into our SCADA systems. And with the optimize, that's the biggest area, probably the area where we've been doing it the longest, where we have automated analytics, no human intervention. We have guided analytics, point and click. We have what's called advanced analytics, where on a process line, it can optimize things. It can look for anomalies. It can help with throughput and energy optimization. We also have a thing called predictive asset optimization, where we've taken predictive analytics a lot farther and integrated it with simulation, physics-based simulation. And what this does is it addresses the risk aspects. So it's great that you have a problem very early, and you can take action to fix it, because time is money. But when is the optimal time to do your maintenance? When is the optimal time? Should I shut down now, or should I wait? Can I make it to the next planned outage? And is there something operationally I can do different to improve things? And we have many case studies where this has been super successful to that level of depth. So it's really taking it to the next level. And then we have schedule AI across value chain and many other solutions. But let's take a look at some specifics. Let's look at AI in the design space. These are some of the new things that we're doing. We have a lot of history, a lot of depth, but these are some things that are coming out. One is the intelligent point cloud, part of our point cloud manager solution. What this does is you do a laser scan of a facility, and these days it's pretty easy to do. You scan the facility, you have a 3D drawing that you can actually walk through. You can do a 3D walkthrough, and it's super cool. It helps brownfield facilities move into the digital twin space very quickly. And that's super cool, but the problem is it's a dumb drawing. When you go around, you don't know. It's just a bunch of little dots. And so wouldn't it be cool if you could identify what everything is? So when you click on a tank, or you click on a pipe, click on a valve, it says all these little tiny minuscule dots. You can see the granularity of the dots. They all fit together. And this is a tank, this is a pipe, this is a valve, this is a pump, this is a compressor. But not just any tank, pipe, valve, a specific tank, pipe, valve, and then you can tie it to your engineering information through tagging. And so it makes it intelligent. The intelligent point cloud, by being able to relate all this, AI-infused. We're going to be releasing that first commercial release in first quarter of next year as part of our point cloud manager. Another area is generative design, and I don't mean generative AI per se with large language models. I mean generative design where it creates something for you. You're a design engineer and you want to accelerate, or maybe you're not a design engineer and you want to play around. Well, we're starting with 3D pipe routing. What if you could just tell it what you want and it designs it for you? Here you tell it the start and the end points, and you say, okay, start, end, but I want to put constraints because I don't want it to clash with this other piping or these structural elements. And then I want to set the plane. Maybe I want to put it down low, or I want most of the piping up high because I want to avoid foot traffic. And then it starts to create in 3D these pipes and comes up with different options. And of course, you can modify it from there, but what it's trying to do is solve the very complicated equation of minimizing pipe length and minimizing the number of elbows so that you can keep, you want to keep head loss down and optimize throughput of the pipes. So we're starting with 3D pipe routing. That'll be released targeting this fourth quarter. Before the end of the year, that'll be out. And super excited about it. And then we're going to add HVAC and structural elements and other things to it as well as we continue to move forward. And we have big plans for AI-infused in the engineering space. In the operate space, let's look at AI infusion there. We have what's called Vision AI Assistant that we released about 3 years ago, and we're continuing to make it smarter. And it's natively integrated into system platform and unified operations. And if you look down there, you have anomaly detection. That's what we started with. This is good. This is not good. You just use a regular digital camera. And it becomes like a smart sensor. And it can help with product quality. It could help with a space. You got smoke coming in a space or somebody's in a space. It's not what's normal. It'll alert you. And we have discrete state, like this is open, this is shut, or it's a hopper, full, half full, empty, or red or blue. And then we added more complicated things. Like in an image, maybe you don't want the whole image to be monitored. You only want, the upper left might have foot traffic, people walking by, you want to ignore that. Let's just look at the lower right. And then, from a product perspective, maybe I realize there's going to be defects. There'll be a burr here or there, but some burr is, some defect is acceptable, but then there's a point where it's not acceptable. You can set that. And then the last thing is user pipeline, where you can drag and drop all these different capabilities together to create your own relatively complicated vision analysis. Super simple drag and drop. And then when you put it into unified operations, you can look at it from an operator perspective or an engineer perspective or whoever, technician, you can look big picture, look at the red dots, drill down, see where the issues are, and then you're going to have visual images because it captures it, it timestamps it, it shows you the visual image of the problem, of the defect, and you can dispatch crews to fix it. And from an operator perspective, it gives you that visibility, that wide range, because usually you're thinking time series data and so forth, maybe AI-driven time series data, but this becomes another type of smart sensor, 24/7 eyes. And then in the optimized space, we've been doing this for many years where you start with historical and real-time data and apply predictive analytics to it, days, weeks, months before a problem occurs. Then we added prescriptive. What sensors apply to the issue? Using AI to determine, is this an outlet pressure problem? Is this a bearing vibration problem, a temperature problem? What is the root cause? And then what is the actual physical root cause? Is it a rotor problem or a blade pitch problem or a lube oil problem? And then we added, and then what do I need to do to fix it from a fault diagnostic perspective? And then we added prognostics. That's forecasting. So predictive analytics is here and now looking for deviations that are likely to get worse. Prognostics are forecasting, using things like deep learning and statistical analysis. And you're forecasting out what's the remaining useful life of an asset? What are things going to look like in 3 weeks? And so it provides valuable tools. And then from there, we've added, like I mentioned with predictive asset optimization, physics-based simulation and optimization to really look at the risk-based aspects. And we've done more things with AI and simulation. We've done what's called gray box modeling, where you take physics-based simulation and replace some of the components with AI. A good example is carbon capture unit, because from a physics perspective, it takes it a long time to converge, minutes or tens of minutes to converge, and that's slow. What if you could use AI and converge in a second? And then, so the output of the physics-based models feeds the AI model, and the AI model output feeds back into the physics model. And if you could run this in near real time with carbon capture and other stuff, that makes it really, really powerful. And so that's an example of gray box modeling. Many, many components. From a customer perspective, you could build your own, and we have many models built as well that can plug and play with physics-based models. Then there's autonomous operations. And this is something that's very exciting because we've partnered with NVIDIA. And there's going to be a presentation after this. I encourage you to stay. It's in this room on this topic. But just to give an overview, this is taking dynamic simulation and training NVIDIA's reinforcement learning engine to create a brain, to create this super intellect that can optimize set points. Now, you're probably thinking, okay, well, if you're familiar, Yeah, we've been optimizing set points for a long time in steady state, but not in transients. So what about a startup? What about a massive change of feed level? Or a big disruption, an upset in a plant, in a facility? Usually it takes experienced operators hours and hours to get the set points to stabilize things again, if they are able to. And in some cases, they have to shut down and start back up. With this, because we use dynamic simulation and blast it with every possible scenario, good and bad, it knows what the set point should be, and it can tell you super fast, and it optimizes it. And so when you're training it, here's an example of training it, you're seeing they converge. You're feeding it with every situation, good and bad, and it's going to converge on the set points for all this. This is happening in the background. You're just blasting it with data, and then what the result is this intellect, this brain that can control transients. So we've had some good successes with there, and we're looking at some big engagements coming up. So super excited. I encourage you to stick around for that presentation. And then last thing I wanted to touch on is unify and humanize. So what do I mean by that? Well, let's think outside the box with AI. You know, you probably used dozens of software packages, and some you're really good at and some you're not, because you had to learn the menus, you got to learn the button clicks, you got to learn the drop downs and how to use them, right? A lot of training. Why do you have to do that? Why can't you just ask the system, you know, a little Star Trek-like, right? So, but why can't you just ask the system, build me a simulation model, or build me a SCADA screen, build me a P&ID, build me a dashboard? Why can't you do that? Well, you should be able to. We need to lower the barrier of entry for software using AI. And it's not just one type of AI, you use multiple types of AI together. Well, when you use GenAI with large language models, you're thinking ChatGPT. Well, this is not ChatGPT. This is knowledge linking. This is something that it's patent pending for AVEVA, and it automatically looks for relationships among data, engineering data, PDF manuals. It's looking for events and time series data, all types of data. And it relates them together. And if you do have a data hierarchy or data model, it'll use that as well and be even better. And then we have the ability to ask it objective-driven questions, complicated questions. So a simple question would be, what was the maximum output of Unit 3 last month? You could trend that, you can get that information, right, today, using data. But using AI, you can look at things like, why is my compressor running with lower efficiency now than it did previously? And you can ask it various questions and dig in, and it'll break some of these questions down into subqueries against a large language model. But the key with knowledge linking is we never blend your data with the large language model. We don't train it. And we don't blend your data with any other customer data. So it keeps secure, but even equally important to security is that it grounds it. We built intelligent agents, intelligent interfaces, tools as we call them, into the various types of data, and it understands industrial data so that it minimizes hallucinations to give you the most accurate responses possible. And this is all knowledge linking. Now, take it to the next level, we partnered with Microsoft, and we're working on the generative side of things to do things like automated dashboards. Describe a dashboard. Give me an energy management dashboard with a pie chart and a stack bar and this and that and these types of tags. And Lori's got a really cool demo to show you on that. So where are we headed with all this? So I showed you a lot of stuff. Again, we want to lower the barrier to entry, because when you're talking neural nets and deep learning and genetic algorithms, it can be intimidating. It shouldn't be. You just tell it what you want and it'll give you the answer, right? So that'll be the front end to other types of AI, other types of analytics, other types of processes. But we're starting on the data and information level. That's what's commercially available today as our industrial AI assistant. Ask it questions, and if you're familiar with Industry 4.0, that's the decision twin. Industry 5.0 is AI and humans working alongside each other. Then we move to the functional level, like build me a dashboard or build me a screen. And then ultimately, it's going to converge and be a unified user experience in our Connect platform, so that it lowers the barrier, so that when you're coming in, you don't have to be an expert at all these different types of software, engineering software and MES software and time series and building screens and so forth. You can just get in there and get started. Experts are still going to use the menus and all the advanced features, but lower the barrier of entry so it's a unified experience. Let's unify the capabilities end to end. Design, operate, optimize. So now I'm going to turn it over to Lori to go into more depth on Industrial AI Assistant and show a really cool demo.
Thanks, Jim. Thanks, Jim. So for those of you who were here last year, you probably saw we had a pretty ambitious demo that we shared of our Industrial AI Assistant. Rob McGreevy showed it on the main stage. We showed it in some breakout presentations. And then we got back to the office and we realized we had to actually deliver it now because last year it was just a demo. But I'm really happy to say that we did as of last week. It's out in production and it's available for all of our Connect visualization customers to request. Some of the key areas I want to talk about with this is really starting with what Jim was talking about, that humanized interface, natural language. Rather than figuring out how to build a query or asking for really specific details, you can talk to the AI assistant as though it's a coworker, as though it's one of your colleagues. So that ability to just ask for what you want and the Industrial AI Assistant will figure out where to get that information and bring you a nice formatted answer. The assistant is really good at searching and summarizing your content. So things like your real-time tags, your streams, your asset information, documents. It goes out, it finds it, and it brings it back in an easy to consume and easy to understand format. We added this year citations as part of our, we're really been focused on really responsible use of AI, making sure that we're being careful and avoiding any pitfalls because we really want to build confidence. We really believe this is the key to our future with this. So traceability and transparency are really important. So we've added citations that give you the date and time that we're looking at, the specific tags, the specific asset information. We're not trying to take the human out of the loop. We want the human to review the information that was used to make your answer and make sure that it is the correct information and always validate. And if it's not the right thing, you can go back and adjust. And last, we have inline generation of content. So if you ask a question, we'll give you a summary, things like minimums, maximums, counts. But we also give you right in line a chart so you can visually scan and see the history right there in the screen. I want to talk a little bit about how we've architected this. It starts on the left with our Connect visualization interface, and you open up your assistant and you type in a question, such as, what was the average output of my wind farm for the last week? And this is where it moves over, it gets passed to our AI orchestrator, and this is really the whole AVEVA secret sauce here. The AI orchestrator then passes that request using a secure link using Microsoft Azure OpenAI. And then the large language model takes your request and breaks it down into pieces. Then we take those pieces and we figure out which tools to talk to. So we have a different tool that we've developed for each type of data that you have in your Connect system. So for example, if it needs to figure out what the wind farm turbines are, it would go to the assets tool, and then that would tell us which tags are measuring the output. So it'd gather up all of that data, and then we would pass it back to the large language model to help us format it. It would give you the charts, the summaries, and break it down in a really easy to read format. A couple of other things I want to point out on this architecture diagram. We've got all of our data. Right now it's Connect data sources, and those will be expanding over time. On the right there, we have what we call our semantic indexing, and we've built a hybrid indexing technique that takes advantage of both semantic indexing, which means it can take into account your intent and your context. So you don't need to know the specific name of a tag or the specific name of an asset or a keyword. You can type in a word. So for example, there where we're asking for the output of Hornsea Wind Farm, but maybe your tag is called production. It can figure out that that's what you meant. So rather than needing to know specific keywords or specific wording, we can figure out what you're asking for and give you the correct information. The indexer service on the bottom right keeps those indexes all up to date. So anytime there's an update, it keeps it up to date so you don't have to do anything. It's all managed by AVEVA in our cloud. We also have the yellow security tag here, which indicates Connect user security, is making sure that nobody has access to any information that you haven't explicitly given them permission to see. And then on the bottom, this is new, but I want to point out that we have built this to be flexible and expandable. So in the future, you will see custom tools that will allow you to get to other types of information, whether it's a partner or some other software. It's an expandable architecture that will allow more information in the future. So as ChatGPT rolled out last year, a lot of headlines, a lot of concerns, and so we worked really hard with both our legal team and our technical team to develop a set of good practices to make sure that we avoid a lot of those pitfalls. So starting on left to right here, when we talk about guardrails, we've set the tone. We introduced the assistant as a helpful assistant, and the focus is really on industrial questions. So if a question is asked that's not in the industrial space, we're just going to tell you, as an AI assistant, as an industrial AI assistant, I can't answer that question. We have a built-in critique to keep the cycle efficient and make sure we're getting good answers. In the middle, when we talk about grounding, Jim talked about this, but it's really important. We're getting the answers from your data that's in Connect. We're not going out to the internet and searching for other information. We're using your data as the basis for these answers. So that really helps us get good answers and the right answers, and then we let you check those answers with our citations. So take a look at what tags we used, what time range, what assets. Make sure that we did it the way you would, and if we didn't, you can adjust your question and make it what you need. And last but certainly not least, security and property. The LLM, Jim mentioned this as well, is never trained on your data. It's stateless, it's fixed, it's sitting there, static. And when your data is sent to it, when we're evaluating your question or looking at things, we have an agreement that your data will not be used for training and it will not be saved. It will be immediately thrown away. And then the user context part, again, Connect user security keeps everything nice and safe. So let's look at a little demo. This is a new demo for this year. And we've integrated ETAP data, our electrical system, into Connect for this demo. So we start by saying, I received an alert from Hornsey. Are there any new events that I should take a look at? So again, we send this off to the LLM to figure out what data sources we need to access. It goes out, it finds a bunch of event data. It's giving us a summary here of total durations. It's telling us what the status was, why the breakers were down. Nice and easy to see. You can see there's links there to click on the assets to get more details. We noticed that there's 8 turbines that are tripping with open breakers, and so we can ask a follow-up question. What kind of faults would cause this? We get some more specific information from our document system. We learn what the common causes of this might be. And next we can follow up and we ask for an SLD. And for the electrical engineers in the crowd, we'll see that it knew that an SLD was a single line diagram, and we can open up this diagram and we can look at the connections and how things are related. We could also have clicked on some of those links in there if we wanted to go deeper. But now that we realize that our wind farm is at a lower output, we also know that this is going to impact, we're going to have to buy power because we're powering a plant with this. And it's also going to impact our sustainability measures. So first we're looking at our import-export power here, and so we see that we're importing power, and so this is costing us money. And next we're going to look at our sustainability impact here. So can we compare our CO2 for today versus when we were not having this problem? And it goes out, it grabs the information, and it's telling us the impact, and that yes, our CO2 is higher. And it gives us a nice analysis and a summary. We get some charts in line so we can see what the history of it was. And now we're going to show some new capabilities. This is our new dashboard generation capability. So we've asked it to create a dashboard with a line chart and with some tags on it. And it brings up a link to our dashboard. So it tells us, here's your dashboard. You can click on the link, open the dashboard. Next, we can create some modifications to it. So we want to change the axis setup here. So we're going to ask it to change it from a single axis to a multiple axis trend. And we're going to change the title of the graph. So we send the request, and we apply the update to the dashboard. Now we're going to add a pie chart to the dashboard. We tell it which tags we want. We give it some specific instructions. And these instructions are pretty specific right now. Like Jim said, we're going to go to more implicit instructions. But the beginning part here is you have to pretty much tell it exactly what you want to do. But again, in English, and you don't have to figure out which buttons to push or how to do it. So now we've got our dashboards, and now one of the really nice things with using this is now we've had this conversation, and we can ask it to summarize the conversation. Give me notes of what we've talked about so I can share these with my colleagues. And so it gives me a nice summary of all the information we looked at, the things that we did, in a very easy to consume format, and we can copy and paste this and send this off to our colleagues. So I'd like to share the release plan. As I mentioned, we were in Lighthouse in September with a set of customers. We had several customers using this with the basic capabilities of connect data streams and events. Right now, this month, we're releasing kind of the full capabilities that we planned from last year, which includes documents from AIM, being able to ask specific questions. In the demo Rob showed yesterday, he asked a specific question in a document. Asking questions about the Connect visualization help. We've added chat history management, which allows you to go back to previously asked questions and answers, and also to favorite questions that you want to maybe ask again another day, see how things are going. We're introducing guided examples. When you start using these tools, the first time I used ChatGPT or Copilot, you're not sure where to even start. So we're going to provide some starting points, some easy click on, show me this, show me that. And then also voice to text capability. So if your hands are dirty or you don't have access to a keyboard, you could use your microphone to ask a question. And then from there on, we'll be on a continuous release cycle. Connect Visualization releases about every 3 weeks, and we'll be introducing new capabilities right along with that release cycle. We'll be working toward the generative dashboard capabilities, which should lead into many other generative capabilities. The dashboards will be first, but we'll lead into creating other things, as Jim mentioned. And then we'll also be adding more Connect data sources and integration capabilities and integration into search. And with that concludes the Industrial AI Assistant. Thanks so much for your time. If you'd like to learn more about what we're doing here at AVEVA with AI, we encourage you to stay for the next session, which is a co-presentation between AVEVA and NVIDIA. There's also a presentation this afternoon with Microsoft with some sustainability information, and then another one with predictive analytics and AVEVA and Drax presenting together. So thank you very much. We appreciate your time.